In this playlist, I'm going over every algebra question that's on the SAT. This is part 12, going over systems of linear equations in two variables. These are all of the hard questions. So when I say these are the hard questions, that means they're all 3 out of 3 difficulty on the difficulty rating on the SAT online question bank. Each of these questions, as I said, is in the domain algebra and the skill systems of two linear equations in two variables. For every question, there's a unique question ID. You can see that here in the top left. Those question IDs also are going to be listed in the video description. So if you look there, you can see the video description with the question ID and a timestamp for each question that tells you the exact minute and second where I start going over that problem. And there will be a brief description of what topics covered in that question. And all of these will be related to systems, but I'll get a little bit more specific with them. So if we dive right in, here's our first question. And we have this system here. The two lines seem to meet at this point. That's 8 over and 0 up. One of them has a steeper slope, so it's going down faster. They're both negative slope. This one has a slightly flatter slope. So what system of linear equations is represented by the lines shown? Now, if we look at this, they haven't separated them super well. I'm assuming that they mean to have like one x and one y in each equation. So there should be more of a space separating each of these 32s from the negatives before the coefficient for the x and the following equation. So one of the equations over here and one of the equations over here. Well, none of these equations are in slope-intercept form. None of them are in y equals mx plus b. That would be helpful if we knew what the y-intercepts were, because then we could use the b value for the y-intercept, or use the slope to figure it out like that. Now you could convert it into that if that's what you're more comfortable with. I'm going to show how you can just use it from the standard form that they give you. Now with standard form, that's ax plus by equals c. You can find the slope. So the slope will just be equal to negative a over b. And the y-intercept, the b value is what I wrote here. I guess we could just call that y-int. So the y-intercept is equal to c over b. You're just going to end up dividing the c by this b once you get the y term alone. All right, so you could use that if you'd like, as I said, or you could also put it into slope-intercept form. The other thing that we could do is figure out what the different intercepts are. So figure out what the x-intercept is. That's when y is equal to 0. Here it should be equal to 8, 0. And then we could also use these two y-intercepts, which are when x is equal to 0. So for one of them, the y-intercept should be somewhere between 3 and 4. It looks a lot closer to the 3. And the other one should be about halfway between 6 and 7. Looking at this first equation, again, both of them should have this point, 8, 0. We can just plug these points both in. So when x is 8, y should be 0. So let's try it for this equation. 8 times 8 plus 4 times 0 should be equal to 32. 8 times 8 is 64. 4 times 0 is 0. 64 plus 0 equals 32. 64 plus 0 is 64. Is 64 equal to 32? It is not. So that means A is not the answer. We don't even have to check the second equation, because if the first equation doesn't work, right, both of these equations are supposed to pass through this point, 8, 0. So if we've ruled out one of the equations, then we can rule out that entire answer choice. Next, we have 8x minus 4y equals 32. So let's try the same thing. Plug in 8 for x. 8 times 8 plus, or actually it's minus 4 times 0. This is going to end up giving us the same thing, because negative 4 times 0 is the same as positive 4 times 0. We still get the 8 times 8 is 64. 64 minus 0 is not equal to 32. 64 not equal to 32. So we can also cross off b. Again, we don't even have to check this second equation because we've already ruled it out with that first equation. Both of these lines should be passing through this point, 8, 0. Next, we can go to this equation. 4x minus 10y equals 32. So 4 times 8 minus 10 times 0 equals 32. 4 times 8 is 32. 32 minus 0 equal to 32. So that checks out. Right? 32 is equal to 32. That doesn't mean C is the answer. It just means we can't rule that out from this first equation and this one point here. Now we can do the same thing with this D here. We plug in 4 times 8 plus 10 times 0 equals 32. 4 times 8 is 32. 32 plus 0 is equal to 32. So 32 equals 32, that checks out. So again, that doesn't prove D is the right answer. It just means we can't rule it out using this point 8, 0. So both first equations for C and D do pass through 8, 0. Now we could also plug in 8, 0 to the second equation for each one, because it should work again for both equations. So we do negative 8 times 8 plus 10 times 0 equals negative 64. Negative 8 times 8 is negative 64. 64 plus 0 is negative 64. So negative 64 is equal to negative 64. So this equation also passes the test of going through that point 8 comma 0, again, that doesn't mean that this is the right answer. It just means that you can't rule it out. Because if we do the same thing down here with negative 8 times 8, that's negative 64, minus 10 times 0, that's also going to be negative 64 equals negative 64. So using this point 8 comma 0, we can't rule out the first or the second equation in C or D. So we know it's going to be either C or D, but we're going to have to use another point. The options we have, we could use the y-intercepts, right, the ones that pass here. The thing with that is you do have to realize we're going to be estimating the point values then, because we don't know, right, is this 6.4 or is this 6.5? Is this, right, 3.2 or 3.3, something like that. We could try to find another lattice point. The lattice point would be where it passes through the actual point like that. So it looks like we've got one at 3 over 2 up like that. So 3 comma 2. And for the other equation, we've got one here that is 3 comma 4. Right, so we can use that lattice point, and then it's going to work out a little bit better. And if you want to just plug in 0 comma 6 point, it looks like 6.4, then you can see if that works, or if it gets something that's very close to that, then you know, right, it's probably correct. Same thing here, 0 and 3 point, I don't know if it's 3.2 or 3.4, just use 3.2 because it's half of 6.4, right? And that should work for one of the equations for the answer that's correct. I'm just going to use, again, these lattice points. So I'm going to use the 3 comma 4 and the 3 comma 2. So now we just have to figure out where you would plug it in. I'm going to assume that the one that's 3 comma 2 will go into the answer that ends up being 32. So I'm going to plug that one into the first equation for each of them. So C, 4 times 3 minus 10 times y should be 2. Now, the benefit with doing the y-intercepts is it's easier math because then one of those things is getting multiplied by 0, so you don't have to worry about it after that. But it's not that hard to multiply 10 by 2, 4 by 3. 4 times 3 gives us 12, minus 10 times 2 is 20. So 12 minus 20 is not equal to 32. That's going to be negative 8. So negative 8 is not equal to 32. So that doesn't work for that equation. Now, again, that doesn't necessarily mean we can rule it out because it could be that it goes into the other equation, but I don't think so. Let's try D now. So using this D equation, 4x plus 10y, again, using that point 3 comma 2, right? X is 3, y is 2. So 4 times 3 plus 10 times 2 equals 32. 4 times 3 is 12, plus 10 times 2 is 20. And 12 plus 20 is, in fact, 32. So 32 is equal to 32. That checks out for the first equation of D. Now, if we try the point for the other equation, this 3 comma 4, for the other equation, we get negative 8 times x, and x should be 3. And we're using this point 3 comma 4. So negative 8 times 3 minus 10 times 4, and I'm using the one from D here, and that should be equal to negative 64. Let's check. Negative 8 times 3 is negative 24, minus 10 times 4 is minus 40. Negative 24 minus 40 is negative 64. So this equation does work for that point 3 comma 4. All right, so that verifies that D will work. We already said C didn't work for that one. And the other thing you could do, if you want to feel more confident about ruling this out, just plug in 3 for x and then solve for y and see if one of them is 2, one of them is 4. In this case, 4 times 3 is 12. So 12 minus 10 times y equals 32. Then that would mean you have to basically turn this negative 10, multiply it by something to make it into positive 20. So y would have to be negative 2. 3 comma negative 2, that point is down here. That's not on any of the lines. Right? So we know that's not going to be one of these lines. Right, so let's say I can rule it out. So I know this was like a kind of a long way to do it, just plugging in points to find points that were on there. The other thing you could do is just plug these equations into Desmos. And you could do it for all 4 and then see which one looks the most like this and then make sure that it is like it. But the other thing that we could do, since I already know it's D, I'm just going to plug in the equation for D into Desmos. So I'm going to write it down here. Like when you're doing the test, you do probably split screen, but it's going to be 4x plus 10y equals 32 for one of the equations, and negative 8x minus 10y equals negative 64 for the other equation. And now I go to Desmos, and I'll just type those equations in. So we have 4x plus 10y equals 32. That does look like one of those equations, right? One of those lines. It's passing through this point between 3 and 4. Looks like 3.2. And then it does pass through this point down here, 8 comma 0. So that's one of the equations. That seems to match. Then we've got negative 8x minus 10y equals negative 64. Right? That's another line that's going down. This one's going steeper. It's passing through a point up here that looks like 0, 6.4. Right? That's what we estimated that to be. And it's also passing through this 8, 0. And we can even see that they have these points that we were solving for, 3, 2, right there. I don't know why it's not saving that point. Maybe if I plug in, I'll just plug in x equals 3. And then now we have those intersection points, 3, 2, and 3, 4. So those do pass through those other points that we found on there. You don't have to use that to verify, but you can see that this is the system of equations. So again, if you don't want to do all of that algebra, this would be a faster solution. Just you could type in all of the equations. To me, I would feel a little bit like that's tedious just to type in. You'd have to do 8 different equations to really verify that you have the correct answer. I guess if you happen to get a match on A or B, then you don't have to type in the ones after that if you feel 100% confident on it. But yeah, this is another way to do it. Again, you could have also converted this equation into slope-intercept form and then use that to find what the y-intercepts would be. That would be, probably equally fast, potentially even faster if you're more experienced with doing that. You could also just plug in 0 for x, plug in 0 for y, find all of the y-intercepts, the x-intercepts for the equations like that. So there's a lot of ways you can do this. I just showed one way that you can do it algebraically, plugging in points. All right, next one. We've got this system of equations here. Let me see where this, I think it's supposed to end after the 12, so it should be like that. So 2 times the quantity 8x plus 4 times the quantity 7y equals 12 is one equation. And the next one, negative 2 times the quantity 8x plus 4 times the quantity 7y equals 12. The solution to the given system of equations is x, y. What is the value of 8x plus 7y? Just looking at this, 8x plus 7y. You could solve for x and then solve for y. You just have to use either substitution or elimination. You could get it that way. And then from there, once you have x and y, you can plug them back into this, plug in your x value, so 8 times that, and then plus 7 times your y value that you calculate. And then that would be your answer. That's one way to do it, perfectly fine. That's how probably a lot of students might do it in my class, because in general, we would work through problems to solve for x, y, right? You're not solving for 8x plus 7y. But because they're asking for this thing that's a little bit weird, that kind of indicates to you there might be a shortcut, or there might be a way that 8x plus 7y appears in the problem. And if we look, we're multiplying 2 times 8x here, we're multiplying 4 by 7y here, multiplying negative 2 by 8x here, and 4 by positive 7y there. So 8x and 7y are appearing in this problem, which means that there might be a way to just get it to be equal to 8x plus 7y, or we could, instead of solving for x, solving for y, we could solve for 8x and for 7y. So the way that I'm going to show you do that is I'm going to change 8x to be a, right? 8x is equal to a, and I just assigned that. And then I'm going to say that 7y is equal to b, which means that my final answer is not going to be something I have to think of as 8 times a variable plus 7 times a variable. I'm just going to say it's a plus b. Now, if we write this out, we get 2a, right? I'm rewriting this first equation, 2a plus 4b, and I'm just substituting a in place of the 8x, b in place of the 7y. That should be equal to 12. And then for the other equation, we have negative 2a plus 4b is equal to 12 as well. So looking at it here, it's already set up to do elimination, right? We could just add these two equations together, right? Add the left sides of them to each other, add the right sides of them to each other, and we would get, right, that would say 2a plus negative 2a is 0, 4b plus 4b is 8b, so 8b is equal to 12 plus 12 is 24. And then divide both sides by 8, we get that b is equal to 3. Now once you have this, you could plug that 3 back into one of these equations, so you could say, maybe plug it into this first equation, we get 2a plus, instead of 4 times b, we'll do 4 times the value of b, which is 3. So 4 times 3 is equal to 12. That gives us that 2a plus 12 is equal to 12. And then what do you have to add to 12 to get 12? 0. Or I could do subtract 12 from both sides. That means that 2a is equal to 0. And then 0 divided by 2 is still 0. So that means that a is equal to 0. All right, so a plus b is just 0 plus 3. 0 plus 3 is 3. 3 would be our answer. That's a perfectly good way to do it there. Now, sometimes there will be ways that you can manipulate it so that you just, without even solving for one of the variables and then the other one, you can just get directly to that answer. So the a plus b, or you think of it as 8x plus 7y. I guess there could be a way to do this. I'm trying to think what you'd have to multiply. I think you'd have to multiply both of them by something or multiply one of them by a fraction. it would end up just being harder than solving for one of the variables and then the other. So I think this is probably the easiest way to do it. If you solved for what actually x was and then what y was, it would still work out fine. I mean, if 8 times x is equal to 0, that means that x is also 0. So if you find that that's 0, that would mean that 7 times y is 3. So y would just be 3 divided by 7, 3/7. So I mean, they saved us from having to deal with fractions, I guess. It saved a couple of steps. But this is just a little trick that you can use if they ask for something like that. Just always be mindful, what are they asking for? Because a lot of students might just rush. And I mean, the nice thing is with a system of equations, the answer is often x comma y, right? That's like the answer that you solve for. So you're not just going to solve for one variable and think I'm done out of habit. You're used to going, okay, I have to do x comma y. And then on the SAT, right, if it's not asking for x comma y, there's not like an easy way that you would bubble in that answer by mistake. So hopefully you would catch yourself. Just always look what they're asking for, even if it's for something weird. I like to look at the beginning specifically so I can strategize the way I solve for it. So it's like the most efficient way to get to my answer, at least the most efficient way I can think of quickly. But again, always revisit that at the end. Did I solve for it correctly? If they're asking for a plus b, which again was 8x plus 7y, and that would be 3. 3x equals 36y minus 45. One of the two equations in a system of linear equations is given. That's this equation up here. The system has no solution. So no solution. We know no solution is true for linear equations when they are parallel lines. Because a solution for a linear system of equations would be where they cross. And for most systems of equations, most pairs of lines, they will cross at one point exactly. Right? Whether they're both going up and one of them's going up at a steeper rate, or they're both going down and one's going up going down at a steeper rate, or you could have one going up and one going down. Right? They will cross somewhere. You also have instances where you get the same line twice, and sometimes it's written in a way that it looks like it's two different lines. So say like x plus y equals 5, and then if you double all the terms of the left side and all the terms of the right side, 2x plus 2y equals 10, for instance, right? That would still be the same line if you graph it. It just it appears different, but we scaled up every part of it the same. So it's just like instead of talking about this point, you might be talking about a point up here, but it's still on that same line. Those are going to intersect at every point that's on the line, right? It's not every point that exists in the coordinate axes or in the coordinate plane, but they're identical lines. So every point that's on one of the lines is also on the other line. So they have infinite solutions in that case. We are looking again for one that has no solution. So no solution if there are two parallel lines. Parallel by definition means they never cross. Two lines with the same slope but different y-intercepts. So if they never cross, then that would mean there are no solutions. Which equation could be the second equation in this system? We just want to find an equation that has the same slope as this equation up here. Now, if you wanted to use Desmos, you could plug this equation into Desmos and then one by one plug all the other options and see which one is parallel, right? It's pretty apparent when you have a graph, right? If they're going up at the same rate, if they never cross, you could zoom out and see that they still will never cross. But I'm just going to show you how you can do it algebraically. So quickly, if we want to find the slope of this one, it's not in standard form. Standard form is ax plus by equals c for a linear equation. So usually the slope would be negative a divided by b. But I prefer anyway just getting it into slope-intercept form because they don't have to memorize anything like this. You can't mess it up just by incorrectly remembering it. So to get it into slope-intercept form, we want to get into y equals mx plus b. So get the y alone. And the first step for getting y alone, if you have 3x equals 36y minus 45, would be to add 45 to both sides. So we add 45 over here, add 45 over here. Gives us 3x plus 45 is equal to 36y. And now to get 1y instead of 36 times y, just divide everything by 36. So 3 divided by 36, those both have a factor of 3 in them, so we divide them both by 3. This will just become 1x, the 36 will become 12. So we get 1/12 x plus 45 over 36. We don't really care about this part. I mean, you could simplify that a little bit, like they're both multiples of 3, so this becomes 15 over 12. They're still both multiples of 3, so I guess they're both multiples of 9, I could have said in the first place. So this becomes 5, this becomes 4, so it's plus 5/4. Again, that doesn't really matter for this, right? The y-intercept of this line doesn't matter, because we just want to find one that's parallel. I guess it does matter in the fact that for it to be no solution, they have to have two different y-intercepts. So as long as we know that the y-intercept is not the same, then we know they're not the same line. Because if they were the same y-intercept and the same slope, infinite solutions like we talked about over here. We want to find one that has no solutions. All right, so as long as the y-intercept is not 5/4, we have y equals 1/12 x plus 5/4, which means our slope is this coefficient from the x term, which is 1/12. So our slope is 1/12 for the first line. If we want to find a parallel line, so parallel line will have no solution, then we need to find one that has a slope of 1/12. Okay, starting here, x equals 4y. To get the y alone, we have to divide both sides by 4. So divided by 4, gives me that y is equal to 1/4 x. 1/4 will be the slope here. That's what you're multiplying x by. That's not equal to 1/12. So those are not parallel. The next one, we have 1/3 x equals 4y. So same thing, to get the y alone, we have to divide both sides by 4, the coefficient in front of the y. And 1/3 divided by 4 is 1/12. So this is y equals 1/12 x. And because there's no plus b here, that means that your b value, your y-intercept, is 0. And the only thing we hear about the y-intercept is that it's not equal to 5/4. 0 is not the same as 5/4. So this line will be a parallel line. They have the same slope, different y-intercepts. B is the correct answer. Now, if you want to just verify that C and D are also not correct, if you were rushing on the test and you felt really confident in B, like as long as you make sure you didn't make any math errors, you could just move on right after you answer B. I like to do process elimination even after I have my answer. Like a lot of times process elimination is what you would use if you don't know how to answer it. It's like, all right, well, I don't know what the answer is, but I can rule out it's not A, it's not this, so I have a better chance guessing. But if you have the answer, process of elimination can just help you know, okay, well, I didn't mess up, because there's only going to be one right answer on the SAT. So if you think it's B, then just prove it's also not C and D, and then you're even more confident. So x equals 12y minus 15. Again, we mostly care about the slope. So I should add 15 to both sides first, but I'm just going to divide both by 12. Oh, and that would give me 1/12. Okay, so this one, it does have the same slope, but it looks like they're probably going to have the same y-intercept. So I'll rewrite this equation over here. X equals 12y minus 15. Now, to get the y alone, I'll add 15 to both sides. We get that x plus 15 is equal to 12y. And now if we divide both sides by 12, we get that 1/12 x plus 15 over 12. That's actually what we had here originally when I divided both of these, the top and the bottom, by 3. So 15 divided by 3 is 5, 12 divided by 3 is 4. 1/12 x plus 5/4 equals, and over here it would be y. Problem with that, it does have the correct slope that we want, 1/12, but it has that same y-intercept. So this would have infinite solutions, not 0 solutions. So before I kind of mistakenly said, well, the y-intercept doesn't matter. I guess, I corrected myself. I said, I guess it does matter if they happen to have the same y-intercept, but I doubt they do that. They did do that. So that's why C is incorrect. Okay, so you can't just use the slope. Also make sure that your y-intercept is not the same if you're looking for no solutions. And then this last one, I think for this one, I won't have to worry about the y-intercept, because if you divide both sides by 12, 1/3 divided by 12 would be 1/36. This would be 1/36 x. So your slope is 1/36. We don't need the y-intercept to know that this is wrong. It is a different slope. Right? Parallel lines will always have the same slope as each other. All right, so B is your answer. We knew that B was the answer anyway, but we also ruled out those other options. It's not A, it's not a C, it's not D. All right, we have a system of equations here. The spacing is actually okay here. I mean, maybe you could have made it a little bit further below the question ID, but that's fine. If x comma y satisfies the system of equations above, which the system is negative x plus y equals negative 3.5, and x plus 3y equals 9.5, what is the value of y? It says it satisfies that system, which means, right, like that's the solution to that system. That's where they cross the point that is on both of those lines. Now, to solve these, let me look at it closely. We're trying to find the value of y. So we want to get rid of x. So you could substitute in x in terms of y, and then you'd solve for y. Or it looks like this one's set up nicely for elimination. So we have negative x plus y equals negative 3.5 is the first equation. The second one is x plus 3y equals 9.5. We want the value of y. If we add these two equations together, so add the left side to the left side, add the right side to the right side, right? They're two equivalent values and both sides of the equal sign, so you're adding the same value, the same thing to both sides. That's fine. Negative x plus x cancels out, right? That's why I did this elimination like this. Negative x plus x is 0. Y plus 3y is 4y. And then negative 3.5 plus 9.5 would be 6. So we get 4y is equal to 6. And then to get y alone, you just divide both sides by 4. That gives us y equal to 6/4, which is 3/2. Right, so 3/2 is the value of y. We don't even need to figure out what the value of x is, because we already have this y, and that's all they're asking for. Especially if you were in a rush on the test, just leave it at that. You could also put it as a decimal if you prefer. 3/2 is equal to 1.5. Either of those answers should be acceptable. Now, if you do have time, you can check it. So you could just plug in your value of y. We could say negative x plus 1.5 is equal to negative 3.5. Now we've got x plus 1.5 equals that. We subtract 1.5 from both sides to get what negative x is alone. So negative x is equal to negative 5, which means that x is equal to positive 5. Right? So your solution should be 5 comma 1.5 for this system. But we found that using the y value that we used both defined and then using this equation. To verify that that is the right answer, we just plug those same values, 5 comma 1.5, into the second equation and see if it actually works. So when x is 5, 5 plus 3 times our y value we said was 1.5 for the solution should be equal to 9.5. Let's see. 3 times 1.5 is 4.5. So 5 plus 4.5 is in fact equal to 9.5. So that checks out. All right, so that's a way of verifying it. You could also type both of these equations into Desmos and see if the point where they cross is 5 comma 1.5. Or even from the get-go, you could have just typed both of these equations into Desmos and then make sure that you're looking for the y coordinate, because they want what is the value of y for that ordered pair that satisfies both systems, so for that solution. This one really could have been a medium question, especially if they set it up so nicely for elimination. Make sure that you're comfortable with elimination because it's a nice shortcut. But I think the main thing they're testing here is this weird way of wording it, that it satisfies the system of equations. Although they use that, I think, also in some of the easier medium questions. So just make sure that you know that that means, right, it's just the solution for both of those. So we've got a system here. It's another one where they didn't space it very well, but I'm just assuming they usually don't put y's on both sides of the equation. I do that sometimes in my algebra classes for my students, but I don't think the SAT will often do it. So for this system, they'll have 3/2 y minus 1/4 x equals 2/3. And then the next equation starts at negative 3/2 y. Oh no, I was wrong. So this is clearly, like, they wouldn't write 3/2 y 1/2 x, right? There's no, they would put a multiply sign or add, and they wouldn't multiply those in a system of linear equations. So this actually does have y's on both sides. I spoke too soon. I said the SAT very rarely, or SAT doesn't usually do that. They did it in this problem. I mean, it is in the hard section, so that's not shocking, I guess. But we have 3/2 y minus 1/4 x equals 2/3 minus 3/2 y is the first equation. And then the second equation, 1/2 x plus 3/2 equals p times y plus 9/2. So it's got this constant p in front of the y. In the given system of equations, p is a constant. If the system has no solutions, it's another one with no solution, which means it's going to be a set of parallel lines. No solution for a linear system. They never cross. They have to be parallel. So that means they have the same slope, they're going up at the same rate, but they have different y-intercepts. So what is the value of p? Well, I guess, again, we could get it into slope-intercept form. We could also get it into standard form and then just solve for negative b over a, but I think it's easier to get it into slope-intercept form. So I'll start with this first equation. 3/2 y minus 1/4 x equals 2/3 minus 3/2 y. Now when I say it's easier, technically for this first equation, it would be easier to get it into standard form because you just add 3/2 y to both sides, and then I guess you can multiply everything by negative. Or, I mean, this technically would be standard form. It would just be a negative 1/4 for your a value. Just use the commutative property of addition, change the order there. But I more mean it's just easier to quickly find what the slope is and what the slope is if they're already in slope-intercept form, and manipulating the equation is not too hard. So again, I'll add 3/2 y to both sides. And 3/2 y plus 3/2 y would give us 6/2 y, or you just say 3y. So 3y minus 1/4 x equals 2/3. Over here, negative 3/2 y and positive 3/2 y will just cancel out. They add up to 0. And now I'll add 1/4 x to both sides, because I could have done that along with that in the first step. But that gives us 3 times y is equal to 1/4 x plus 2/3. Okay, so now that's 3 times y. For slope-intercept form, we're going to get y alone, right? It should be y equals mx plus b. So I'm going to I'm going to divide everything by 3. You have to divide every single term by 3. So 3y divided by 3 is just y. 1/4 divided by 3 is 1/12. This would be 1/12 x plus 2/3 divided by 3 is 2/9. All right, so this is our equation, the first equation. Y equals 1/12 x plus 2/9. Now for the second equation, we can get the y alone, but there will be a divided by p on the other side. So first, I'm going to rewrite the entire equation. We get 1/2 x plus 3/2 equals py plus 9/2. So we'll subtract 9/2 from both sides to get the y terms alone. That gives us 1/2 x positive 3/2 minus 9/2. You have to subtract 3/2 to get to 0, and then you have another 6/2, or another 3, to go down from there. So it would be minus 3. So 1/2 x minus 3 equals py, and then over here, the negative 9/2 plus positive 9/2 will cancel out and add up to 0. All right, so now we've got p times y alone. So to get just y alone, we'll divide everything by p, like this, and that gives 1/2 divided by p will just be 1/2p, right? The p is joining in the denominator because this is what you're dividing the thing by. So 1/2p times x minus 3/p is equal to, and over here p divided by p is 1, so that's equal to y. Right? I guess if you want to put it more in the form that you might be used to, y equals 1/2p x minus 3/p. So we wanted there to be no solution. No solution means that they're parallel lines, and parallel lines mean they will have the same slope and different y-intercept. To find the same slope, the slope of this first one is what you're multiplying x by, so the slope was 1/12. Now, if we want 1/12 to be equal to the slope of the second one, which is 1/2p, that means that 1/2p has to be equal to 1/12. Now, you could multiply both sides by 2, think of it that way as like getting rid of the 1/2. Or what I'll do is just think, what do I have to multiply 2 by to get 12 in your denominator? Like 2 times what is 12? P has to be 6. Again, right? Opposite of times 1/2 would be times 2. You could do that times 2 times 2. 1/12 times 2 is also 1/6. So it'd be 1/p equals that, and you have to do the inverse of both sides. But anyway, p would be 6 to make these the same slope. And now we just need to verify that this would be a different y-intercept. So y-intercept over here is 2/9. If you plug in 6 for p, you'd get that your y-intercept is equal to negative 3/6, which is equal to negative 1/2. Negative 1/2 is not the same as 2/9, so it does check off both of these boxes here. Right? They have the same slope. They're both a slope of 1/12 if p is 6, and they have a different y-intercept. One of them is 2/9, one of them is negative 1/2. Right? So that would be your answer. P equals 6. And you can always just check, what are they asking for? What is the value of p? 6. All right, we have another system here. ax plus by equals 72. And then the second equation, 6x plus 2by equals 56. So we have another two equations here. ax plus by equals 72. And 6x plus 2 times b times y, 2by, equals 56. In the given system of equations, a and b are constants. So this is a constant, and this is a constant. The graphs of these equations in the xy plane intersect at the point 4, y. What is the value of a? So they're intersecting at 4, y, which means when they're equal, x is equal to 4. So the one point where they intersect is where x is equal to 4. We don't know what the y value is, but we could plug in the 4s for the x's, I think. So instead of a times x, it will be a times 4. We could call that 4a plus by equals 72. And then for the other equation, again, plug in 4 for the x, we get 6 times 4 plus 2by equals 56. Right? 6 times 4 gives us 24 here. So 24 plus 2by equals 56. To get this by term alone, we could just subtract 24 from both sides. It gives us 2by is equal to 56 minus 24 is 32. So 2 times by equals 32. And then over here, 4a plus by equals 72. There's not really anything we can simplify. Just make that 4a. But we can see we know the value of 2 times by. So if we want to find by, because there is a by in this first equation, we can divide both sides by 2. 2 divided by 2 is 1. So by is equal to 32/2, which is 16. So by equals 16. We don't know, what of that is coming from the b, what's coming from the y. But we can plug this in for by over here, and we get that 4 times a plus, again, what's equivalent to by is 16. So 4a plus 16 is equal to 72. And now, again, we're trying to solve for the value of a. So if we want to know the value of a, we could just subtract 16 from both sides, get the a's alone. So 4a equals 72 minus 16, which would be, 56. And then now we have 4 times a, we would just 1a. So we divide everything by 4. 4a divided by 4 is just a, and 56 divided by 4, well, 40 divided by 4 is 10, and then 16 divided by 4 is 4, so 10 plus 4 is 14. You can also type that in your calculator. So a would be 14. You could try to check this one. If you plug in that a value over here, 4 times 14 plus by, and then use that to solve for what by is equal to. And I guess to check this one would be a little bit tougher to check. You could plug your a value back in to the equations and see if you could figure out what y is. But I think the fact that you have b times y, it doesn't really matter. As long as you're confident that you did the algebra right. I think for this one, when you check it, maybe just walk through the steps again, or even maybe if you have time, solve the problem again, make sure that you get the right answer. But what's nice with this one is it really is testing your algebra skills, not just how well you can type something into Desmos. Now, what's not nice, that means if you're relying on your Desmos skills, this one's going to be really tough, but just play around with it. If you have a lot of variables or like variables times constants stuff, just always look, what am I trying to solve for? Try to find some way to get that thing alone, whether that means playing around with your variables, using some form of elimination or substitution. Here we did this substitution, figured out what by is equal to. I don't think, oh, b times y, it's going to be something we have to do like quadratics or multiplying variables. It's really complicated. No, it probably means that thing where you're multiplying variables is easily eliminated in some way, right? Either maybe you can solve for what one of those variables is and substitute it in, or you substitute something that is equal to the product of those variables like we had here. B times y is equal to 16. All right, we have another system, and this one is a little bit more confusing where it starts. It looks like this says 2/7 times gx, but I think the space between the 2/7 and the gx is sufficient that that's got to be two separate things. So our first equation appears to be 2/5 times x plus 7/5 y equals 2/7. And then our second equation here is gx plus ky equals 5/2. In the given system of equations, g and k are constants. The system has infinitely many solutions. So infinitely many solutions for a linear system means that they are the same line. So these equations are exactly the same. They might be, right, you might be multiplying both sides by the same factor, but that doesn't change what the equation actually is. So they are the same equation. What is the value of g over k? So we basically have to figure out what values of g and k would make these equations the same. This one I underlined in pink, this one I underlined in orange. And then, again, you have to divide the value of g by the value of k. That will be your answer. So make sure you don't do all of the hard stuff. Don't do all of the algebra correctly and then forget to divide them at the end. Just looking at it, both of them are written in standard form. Standard form for a linear equation is ax plus by equals c. The c term is different because if it was the same, this would be a really easy problem because you just go, all right, well, they're both 2/7 over here. So that means that the coefficients in front of the x and the coefficients in front of the y have to be the same to make them equivalent. So then it would just be like, oh, g is 2/5, k is 7/5. Unfortunately, because they have different c values, we're going to have to do a little bit more work here. So I'm going to think, what would I have to do to this first equation? So this 2/5 times x plus 7/5 times y equals 2/7 to get it so it has the same c value as this second equation. Right? We want to make that into 5/2. Now to do that, we could like subtract 2/7 and then add 5/2, but we don't want to do that because we basically want to have it in this form on the left side, right? We want to have an x term plus a y term and no constant on the left side. Keep it in some form of standard form. Usually, I think of standard form generally meaning that these the coefficients for the x and the y are going to be constants. I don't think it has to be that way. Like I think you could consider this standard form, but that does mean it's not really standardized because there's a lot of different possible answers. But anyway, to get this to be 5/2 without adding a constant on the left side, because if you add or subtract 2/7 or 5/2, you would need to do it on the left side as well. It's an equation, you got to keep it balanced. So what I'm going to do is multiply it by something, because multiplying, you do still have to multiply the left side by something, but if you multiply the x term, multiply the y term by some constant, that will just change the coefficient. It won't change whether or not there is a constant being added to that side. It doesn't change the form of it if it has an ax term and a by term. So I'm going to multiply first by 7/2, because 7/2 will make this into 1, right? 2/7 times its reciprocal, 7/2 is just 1, because 2 divided by 2 is 1, 7 divided by 7 is 1. Now again, if I multiply this by 7/2, I have to multiply all of the other terms by 7/2 as well. So I'm just going to write that to keep track of it. I'm actually going to end up placing that with something else, but you'll see in a second. So that would make you have 1. We don't want to have 1, we want to have 5/2. So now I have to multiply by 5/2. Again, if you multiply the right side by 5/2, then you have to multiply every term on the left side by 5/2. So I guess what I was going to say is instead of multiplying it by 7/2 and then 5/2, you could multiply by the product of those two. 7/2 times 5/2, which is equal to 35/4. Right, so I'm just going to write 35/4 here. If it's easier for you to do times 7/2 and then times 5/2, then go ahead and do that. I'm just doing this more so that it's easier to fit in here on the left side of the equation. All right, so like we said, the 2/7 times the 7/2 cancel out, give you 1. 1 times 5/2 is just 5/2. So we have what we want on the right side. Right now it matches that 5/2 C value for the second equation. But for the left side of the equation, 35, you could do 35 times 2 over 4 times 5, so it'd be 70 over 20. That's fine. Or what I'm going to do is 35 divided by 5 is 7, and then we have 2 divided by 4, you could convert that into 1/2, or you could like take a 2 out of the top and the bottom, so it gives you 7/2. Right? Again, if you had 35 times 2 is 70, over 4 times 5 is 20, 70 over 20, just take a 10 out of both of those, same thing we did, took a 5 out, took a 2 out, 2 out, same as taking a 10 out of both. 70 over 20 is equal to 7/2. Right? So either way, you get that same thing. And then we got this one, so 35 divided by 5, right? Both of them have 5 as a factor, 35 divided by 5 is 7, we get 7 times 7 over 4. 7 times 7 is 49, so that's 49/4 y, and that's equal to 5/2. So now we have it in the form that we want. It's ax plus by equals c, where the c value is 5/2. We've got this equation now. So now we just need to figure out what g and k are. Well, g is supposed to be our coefficient in front of the x term. So g is going to be 7/2, and our k value is the coefficient in front of the y term. So k is equal to 49/4. Okay, so we've got those g and k. They didn't just ask what is g and what is k, they said what is g over k. So now we need to write g over k is equal to 7/2 divided by, now you could write it as a fraction, like fraction over a fraction, but I'm just gonna write it like this, over 49/4. And when you divide by a fraction, you just multiply by the reciprocal. So this is equal to 7/2 times the reciprocal of 49/4 is 4 over 49. So now this is a little easier to visualize for me. That's why I set it up like that. Usually you don't use divide signs like that unless you're typing in a calculator, like maybe after 6th or 7th grade, because you're just gonna usually set it up as a fraction. But for me, this made it a little bit easier here, because now we can take a 7 out of the numerator and denominator of this product here. Right? 7 divided by 7, this would become 1, this would become 7. Right? 49 is 7 squared. And then 4 divided by 2 is 2. So we can take a 2 out of the top and the bottom, left for 2. And that gives us 2 over 7 for our value of g over k. And that's what we're looking for, g over k. So I can just say 2/7 is my answer. Because if you wanted to make that a decimal and round it, you could. I think they would accept that. Just make sure you read closely at the beginning what are their rules as far as rounding. I don't think there's any point in doing that. It's perfectly acceptable to give your answer as a fraction. This is definitely the more exact answer. You don't have to round it. So just do 2 over 7. Make sure if you do a fraction that it is fully reduced, right? Don't give 20 over 70 or something like that. All right, another system here. 7x plus 6y equals 5, and 28x plus 24y equals 20. For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? Are you plugging in r for the x, for a or b, or it looks like r is the y value over here? C looks really annoying. I'm hoping that one of the other ones works so that, I mean, I'll probably still go over it because I'm going over these solutions for you, but this one will be a little bit more annoying to plug in. I mean, it's still just basically like substitution, but you're just substituting all this stuff. So our first equation, I'm gonna write 7 times, this is where our x will go, plus 6y equals 5. And then our second equation is 28x, and you know, leave that space where the x is going, plus 24y equals 20. In the interest of space, I'm just gonna use these same ones and keep erasing it. I know on the real thing, you know, hopefully you have a big piece of paper that you can do a lot of work on. But I'm gonna plug in r first. So I'll plug in r for the x, right? Because for the option A that has r as your x value. And then 7r plus 6y equals 5. Now we just need to solve for y. Oh, I guess this is the other way you could do it, is just get y alone from the get-go. So we could say, right, that you'd subtract 7r from both sides, or you could think of it still as 7x. And that would mean that 6y equals negative 7r plus 5. Divide everything by 6 to get y alone. And we get y, right, because 6 over 6 is 1. So y equals negative 7/6 times r, or you can think of it as times x, because that is our x value, plus 5/6. Okay, so is that the y value that we have here? Negative 6 over 7r. No, they have the reciprocal of the answer, and they do plus 5/7 instead of plus 5/6. So it's not A. That's a shame. Well, we don't even have to worry about doing it for the second equation because we already ruled out A, right? So if it doesn't work for one of the equations, then it's already not satisfying this, because it should be for each real number, which of the following points lies on the graph of each equation. So it has to be both equations. Okay, so we know it's not A. I mean, if we look at B, you're also plugging in R. So this is already in the R form. This says negative 7/6R. Ooh, up here it's positive 7/6R plus 5/6. So that one's off by a negative sign, assuming that I did that right. Minus 7R. Yeah, it should be negative because you have to subtract 7R from both sides. So it's also not B. That kind of stinks because that means we can't just use this strategy to figure it out. Well, I guess what we can do for C might not be as bad as D now that we've done this work. Instead of plugging in R, so I'll make this back into X. X. This should be like that. Right, we know that y will be equal to negative 7/6 times x plus 5/6. Well, our x value now instead of r is this whole thing. So x is equal to r over 4 plus 5. So now I'll just substitute that in. We get y is equal to negative 7/6 times, parentheses, r over 4 plus 5. I put it in parentheses so the whole thing is getting multiplied by negative 7/6 plus 5 over 6. And now when you distribute this, you get y is equal to negative, what is that going to be? 7r over 24 plus negative 7 times 5 would be, I guess it's going to be minus 35 over 6 plus 5 over 6. And then negative 35 over 6 plus 5 over 6, they have common denominators, so you can't combine them. They'll just become negative 30 over 6. So negative 7r over 24. And now negative 30 divided by 6 is just negative 5. So we get negative 5, this is negative 7r over 24. Right, so y should be equal to negative 7r over 24 minus 5, negative r over 4 plus 20. Ooh, so it's not C either. All right, well, if you were rushing, you could go, all right, I eliminated A, B, and C, so it should be D, assuming I didn't mess one of the other ones up. Verify that we didn't mess it up, so I'm going to plug this in now. Now, what we can do, so they gave us, in this case, R is Y, R is not X, right? So you could plug it back into the original part here. So you could go like 7 times X plus 6 times R equals 5, and then get X alone. That might be the smarter way to do it. I'll probably still do that for the second equation because I didn't even simplify the second equation because none of the other ones even passed the test of the first equation. I think for this first equation, I'm going to move the stuff that I did for C. I'm not going to delete it just in case I did make a mistake and then I can maybe catch it and not have to redo the whole thing. But I'm going to plug in place of the X, not r over 4 plus 5, but I'm going to plug in negative 6r over 7 plus 5/7. So this entire thing here. So now y, and if it works, we should be able to simplify that final thing to be r. So let's see. This might be a silly way to do it because I think the way I just said is probably faster, but let's see. I think this would be interesting. So negative 7/6 times the quantity, negative 6r over 7 plus 5/7 plus 5/6. I just plugged this in place of the r, right, the value for r that they had for D. And now we have to distribute this negative 7/6 to both of these terms. So negative 7 over 6 times negative 6 over 7 times r. They're both negative, so the negatives will cancel out. And 7 divided by 7 is 1, 6 divided by 6 is 1. So this just leaves you with positive r. Then we have plus negative 7/6 times positive 5/7. Well, negative times a positive is negative, and then the 7s will cancel. So we're just left with minus 5/6, and then you still have the plus 5/6 at the end. So this actually, oh, maybe this was the faster way to do it, because the negative 5/6 and the positive 5/6 cancel out. We get y is equal to r, which is what we wanted, right? We wanted that. So this does work for the first equation. None of the other ones did. So again, that's another, like if you were in a rush, you could just go, all right, well, I know now very confidently D is going to be the correct answer. But, just to verify it further, we could plug it in here. So we get 28 times x plus 24. In this case, I'll just plug in the y value, which was r, and that should be equal to 20. So now I want to solve for x. So I'm going to get the x terms alone by subtracting 24r from both sides. That leaves me with 28x is equal to, over here we have negative 24r plus 20. Here they cancel. And now I just divide everything by 28 because we have 28 times x, we just want x. So divide by 28, divide by 28, divide by 28 like that. The 28s will cancel here. We have x is equal to, all right, well, 24 and 28 are both multiples of 4. So I can divide them both by 4. Negative 24 divided by 4 is negative 6. 28 divided by 4 is 7. So negative 6/7 r plus, and then 20 and 28, again, both multiples of 4. 20 divided by 4 is 5. 28 divided by 4 is 7. So it should be x equals negative 6/7 r plus 5/7, which is the option here, right? Negative 6/7 r, so 6r over 7 plus 5/7. So that checks for both. All right, so D works for both equations. Again, all of the other ones, A, B, and C, all failed even working for the first equation. So from there, you could have just known it was D, but this proves this point does work for both equations when x is this value and y is this value in terms of r. I really like that. Was a fun question. I mean, this would be annoying if you were really in a time crunch because, right, for one, the fact that they made the correct answer the last option means you have to do all of them, even if you're rushing, or at least have to do 3 of them. And yeah, I mean, it's a little bit ugly. You can see there's a lot of algebra going on here, but I thought that was kind of fun. Here we have a system of equations. So it's negative 12x plus 14y equals 36. And I believe that's the end of it. Again, a lot of these are really not well delineated where one ends and the other one begins. And then we have negative 6x plus 7y equals negative 18. How many solutions does the given system of equations have? All right. Well, just looking at the options immediately, since it's linear systems, and these are 2 linear equations, we can eliminate exactly 2. Because there's no way that 2 lines will cross exactly 2 times. Right? It can work if you have like a quadratic in a line or 2 quadratics or something like that, or even some of the other functions, exponential or whatnot. But for 2 lines, they either cross 1 time, right? Like that's most pairings of lines. If they have 2 different slopes, they're going to cross 1 time. You could have 0 times if they're parallel lines, right? They have the same slope, different y-intercept. They're never going to cross. Or you can have infinite solutions, which means they're the same line, just written usually 2 different ways, because that'd be a little bit too easy if they give you like y equals 2x plus 1 and y equals 2x plus 1. Right? Those are the same line. So yeah, when you graph them, they overlap at every single point that's on the line. So they have infinitely many solutions. So it would be one of those things. So we just have to identify, are these the same line? If they're the same line, then they're infinite. Are they parallel lines? Then they'd be 0. Or are they 2 lines with 2 different slopes? And they have 1 solution. Right, so this would be 1, 0, infinity. All right, so looking at it, they look like they're going to have the same slope because they're both in standard form. And to get the same slope, our slope is going to be, for standard form, ax plus by equals c. Your slope would be equal to negative a over b. Now, in one of my earlier videos, I actually said that it's not worth memorizing the how to get standard form, or how to use standard form to find slope. Like, don't memorize this and don't memorize that b or the y-intercept equals c over a, because it's just as easy to get into slope-intercept form. And I mean, that was my philosophy when I was doing it, but they do use standard form so often on these, especially if you get the hard section, you might be pressed for time depending on how well you can pace it. And if that's the case, then this could save you a significant amount of time. So I would recommend try to be confident in doing it, but also just figure out how to derive this quickly. Right? You go, oh, okay, well, I want to get y alone, so I'm getting minus ax on both sides, and then I have b times y, I want just y, so I'm going to divide everything by b, right? And then you're getting negative a over b. So even if you just do that like 1 time on the test, or if you get to a point where you could do that in your head to to reason it out, because you don't want to accidentally do negative b over a or something like that and mess up the whole problem. But this could save you some time. Anyway, for this problem, you could also think of it as like if they're going to have the same slope, then when you write it in standard form, the ax plus by can be made to be the same. So right, like a and b are in the same proportion to each other. So even though looking at them, like the a's are different, the b's are different from each other right now, but you could see negative 12 is negative 6 times 2, and positive 14 is positive 7 times 2. So we can just multiply this whole equation by 2, right, the left side and the right side, and that gives us negative 6x times 2 is negative 12x, plus 7y times 2 is 14y, and negative 18 times 2 is negative 36. All right, so this is equivalent to this second equation. Now, again, like we said, if the a and b terms can be made to be the same, which they just were, without changing the, the value of the equation, that means that they have the same slope. All right, so we know it's not going to be one solution. I don't know, I just crossed it out with another example of one solution, but right, I'm crossing it off as that's not an option. Right? They have the same slope, so they're either the same line or they're parallel. Now, for them to be the same line, they have to have the same y-intercept. So you could use this to c over a if you go what the y-intercept is, which in this case, this would be positive 3, this one would be negative 3. That's one way to do it. Parallel lines would have two different y-intercepts. Or you could just, right, if you have it so that this side is the same, right, the ax plus by is the same for both equations, which it is, then just compare the c values. The c's should be the same if it's the same line. If they're two different c values, then that means even though they have the same slope, they do have two different y-intercepts. And in this case, they are additive inverses of each other. That doesn't matter, they're two different numbers, right? 36 is a different number from negative 36, so these are not the same line, which means that there are 0 solutions, right? It's going to be two parallel lines. They have the same slope, which again, if you wanted to find it, just do negative a over b. That's negative 12 over 14. So it's positive 12 over 14, which is equal to 6/7. So both of them have a slope of 6/7, and their y-intercepts for one of them, it's negative 36 over negative 12, that's 3. The other one is going to be positive 36 over negative 12, which is negative 3. So two different y-intercepts. I wrote C, that should say y-int. Two different y-intercepts, and usually you use b to represent it. Some people do use c to represent the y-intercept. Think about it in calculus, you always do plus c at the end, right, like that. But it just gets confusing with standard form because it has an a, a b, and a c in it that represent something different. So, those are two different y-intercepts. You could write it that way. I usually just think of it, all right, what do I have to do to manipulate it so the left side is exactly the same as the right side, if that's possible. If it is possible, then you narrow it down to either 0 or infinite solutions. And then see, is the c the same on both? Then they're the same equation, so infinite solutions. Is the c different, right? Is this right side of the equation different? That means they must be parallel lines. So despite the same slope, they do never cross. In August, a car dealer completed 15 more than 3 times the number of sales the car dealer completed in September. In August and September, the car dealer completed 363 sales. How many sales did the car dealer complete in September? So let's make two variables. I'm just going to do A and S. Now, always be careful when you use S that it can look like a 5 if you don't make it curly enough. I mean, it kind of depends how you draw them. Like even that, I just try to intentionally make it not look like a 5. It kind of still looks like a 5. But all right, I'll do it in a specific way. Maybe you even do like a dollar sign or something. Like find some way that you won't mistake it for a 5. Same thing with like, if you use an L, people like to do a curly one because if you just do an L like that, that looks like a 1. Or even Z's are sometimes dangerous if you don't put a line through them or something. So I'm actually going to just add in a little like dollar sign thing through the S for September. Do whatever you do. You can also just make it B, but I want to do it like this. So it says in August. So in August, a car dealer completed 15 more than 3 times the number of sales from September. So that means that A is equal to 15 more, so 15 plus 3 times the number of sales. So that's 3 times S. All right, so that's one of your equations. Right? It's just from this part that in August, 15 more than 3 times S. In August and September, the car dealer completed 363 sales. So when you combine A and S, so A plus S, that's equal to 363. How many sales did the car dealer complete in September? So we're solving for S. And that's what our final answer is. So we want to get the S alone, which means we could do substitution or elimination. And the fastest way is to just get rid of the A, right? So either substitute in something equivalent to a to get rid of the a in one of the equations, or eliminate the a using elimination. What I will do is substitution in this case, because we have a alone in this first equation. So I'm just going to substitute in 15 plus 3s for a in the second equation. So we get 15 plus 3s plus s. Now usually I say when you substitute it and put it in parentheses, you're not multiplying it by anything or whatever, it doesn't really matter. If you put those parentheses by the associative property of addition, it's as if you don't even have them there. So I'm just not even going to put them. But that is a good practice to have. It's just whenever you substitute in, put it in parentheses so you don't forget it when it does matter. All right, so now we have 3s plus s. So combine our like terms. If you have 3 s's, then you have another s. That means you have a total of 4 s's. So 4s plus 15 is equal to 363. And now to get the s's alone, I'm going to subtract 15 from both sides. That leaves me with 4s is equal to 300. It's going to be 48. So 348 is equal to 4 times s. We just want to find s, not 4 times s. So I'm going to divide both sides by 4 to get the s alone. It gives me that s is equal to, well, 348 divided by 4. 100 is 4 times 25. So this is 300 is 75. 48 is 12 times 4. So we had 75 plus 12, which would be 87. So s is equal to 87. Now, if you're in a rush, especially maybe put that in your calculator so you feel a little bit more confident in it. I'll just verify that. I do trust myself, but 348 divided by 4 is 87. Good. But, in case you're worried you might have made a mistake earlier, what you can do is now solve for a using that s, right? So we know a is equal to 15 plus 3 times that 87. And this one I'll just type in my calculator because I'm already checking. So 15 plus 3 times 87 is 276. So a equals 276. And we used this equation to solve for it. So now just see with the other equation, a plus s, we can see, does that actually add up to 363? So 276 is a, plus 87 is what we got for s. So do those add up to 363? They do. Right, so that's just a quick way to check it. Right, that this, if you find the other value using one of the equations, plug that value and the answer that you had in for the other equation. If it works, that is a good sign that your answers are correct. Other thing you could do is type them into Desmos. Now Desmos will plot it on like an x and y axes. Just make sure that you're keeping track of which one's a and which one's s in this case. Or I guess you could have even made them x and y, right? You could have just said, oh, August is x and September is y or whatnot. But just figure out which one you're solving for, and then that intersection point of the two equations that you have, this equation, will be, I guess it would be at, depending on which is x and which is y, either 87, 276 or 276, 87. And keep track of which one is representing September, because that's what we're looking for. That would be your answer. So again, 87 is your answer. Just enter that in and you will be golden. All right, here we have 48x minus 64y equals 48y plus 24. This is ry supposed to be part of that? I mean, they have the plus. You wouldn't just put a plus on its own. But I do think this equation is probably going to have a y in it, and it looks like that's r times y. Hopefully on the real SAT, they've figured out the spacing by now so that these are a lot clearer. But again, equations should be 48x minus 64y equals 48y plus 24. And the second equation should be ry equals 1/8 minus 12x. In the given system of equations, so these equations up here, r is a constant. If the system of equations has no solution, so no solution for a linear system means you have two parallel lines, they're never going to cross, and parallel lines will have the same slope but different y-intercepts. Now that would help if you have them in slope-intercept form, which we could get them into, they're not right now. And they're asking, what is the value of r? So what value of r will make sure that these have the same slope and different y-intercepts, which you generally with this kind of problem, they're not going to have one that says, oh, there's no way to do it. So if you find the r value that gives them the same slope, it should make it so there are different y-intercepts, because again, there's not a way to answer that that's not possible. If you just had a problem that a teacher made, maybe that is, it could be a trick question or they just happen to choose bad numbers for it. But anyway, if we look at this, what they have here, we want to get, I'm going to get it into slope-intercept form. You could also do it using standard form. I actually just recently did a standard form one. I don't know if it was the previous question. I think it was like 2 or 3 ago. but you just have to figure out what would r have to be to make it so you can get the left sides to be the same, and then that the c values, like the right side of the equation when it's in standard form, are different, and that would be parallel lines as well. But I'll just do the slope-intercept form. That's what I'm more comfortable with doing. And here, what we can do, let's rewrite this first equation. So 48x minus 64y is equal to 48y plus 24. So what I'm going to do is add 64y to both sides so that we have all the y's on the right side. And I'm going to subtract 24 from both sides so that the y's are alone. So that will leave us with over here, right, this negative 64y plus 64y cancels out. So we have 48x minus 24 is equal to, and now 48y plus 64y is going to give us 112y, and then our minus 24 and our plus 24 cancel out. Right, so we have our y's alone. Now we want to get just y alone, so we're going to divide everything by 112. So instead of 112 times y, we just have 1 times y, or y. And y is equal to 48 over 112. Well, both of those are multiples of 4. So we could divide 48 divided by 4 is 12. 112 divided by 4, well, it's 100 is 25, and then 12 is 3. So it would be 28. So those are still both multiples of 4. So I guess they're both multiples of 16 to start with. But 12 divided by 4 is 3. 28 divided by 4 is 7. So we can make this into 3/7 x minus, we just said 112 divided by 4 was 28. So this is going to be 28, and then 24 divided by 4 is 6. Those are still both even, so I guess they're both multiples of 8. And we can divide 6 by 2, it gives us 3. 28 by 2 gives us 14. This is minus 3 over 14. If you just put your calculator into like fraction mode or do math frac, you could have simplified those fractions in your calculator. It also depends what your calculator is. I think on the Decimus calculator, they would be able to support that. But I always think it's a valuable skill to be able to reduce your fractions in a comfortable manner. But anyway, we've got this. If you want, you can rewrite it so that the y equals on this side. That's what a lot of people are used to with slope-intercept form. But again, we want to figure out what the slope would be. So our slope here is what we're multiplying x by. Our slope is 3/7. And we also, I guess, technically need to know the y-intercept because the y-intercept should be different. So our y-intercept is negative 3 over 14. All right, so we want it to be the same as this, and we want the y-intercept to be different from negative 3/14. So to get y alone on the second equation is simpler. They're a little bit nice with this because we already have the y terms alone, but it's just r times y. So now to get rid of that times r, you do the opposite of times r is divide by r. You have to do it to every term. So over here it cancels. That leaves us with y is equal to 1/8 divided by r is 1 over 8r. And 12 over r, you just say it's 12 over r times x. Yep. I guess if you want to rewrite this more in standard form, you could say it's y equals negative 12 over r x plus 1 over 8r. Right, so I just did the commutative property of addition, flip those. So we want to have the same slope. And our slope from the first equation was 3/7. So that means that the slope for this one, which is negative 12 over r, so negative 12 over r should be equal to 3/7 if these are parallel lines. So now to get r alone, we're just going to multiply both sides by r. You could also, if you want, you could cross multiply. Right? Like that'd be 3r equals negative 12 times 7, so negative 84. Divide both sides by 3, sorry, as you get the r alone, that give you that r is equal to, what is that, 30 minus 2, so negative 28. So r equals negative 28. You could do it like that, or, I mean, the way I would probably have done it, just multiply both of these by r, and then multiply them by 7/3. So the 7/3 cancels here, r's cancel here. See, negative 12 divided by 3 is 4, so we get 7 times negative 4. That would still give you that r is equal to negative 28. So either of those methods will work to get r once you have this set up, right? That negative 12 over r, right? The slope of this one's equal to the slope of the other one. This is going to be our answer, right? If you're in a rush, just do that. They're not going to give you one that doesn't have an answer. But just to be completely thorough with this, we need to prove that our y-intercepts are different, right? If they're really going to be no solutions. So we could say our y-intercept here, 1 over 8r, has to be different from negative 3 over 14. Okay. So if we plug in negative 28 for r, it would be 1 over 8 times negative 28. And I mean, that's clearly not the same thing, but 8 times 28, that's equal to negative 1 over 224. And we could say definitively negative 1 over 224 is not equal to negative 3/14. So that does check out. Right? They are going to be parallel lines, not the same line twice. Right? They have the same slope, but two different y-intercepts. So r being negative 28 will be our answer. And they just asked, what is the value of r? Just circle negative 28, or I guess when you're entering it in, type it in as negative 28. One last way you could check it is just plug both of these equations into Desmos and use your value of r and see if they do graph as parallel lines. So I'll just show that really quickly. So we have 48x minus 64y equals 48y plus 24. And then ry, we said r for our value was negative 28y equals 1/8 minus 12x. So you can see I'm not even using like the simplified version of this left equation. It's like maybe I simplified it incorrectly. So I'm just going to go right to Desmos, erase our equations from earlier, and let's type in what we had. So it was 48x minus 64y equals 48y plus 24. Here's our line, the equation 1, and then the other one, this is using our value of r, which is negative 28. So negative 28 times y is equal to 1/8 minus 12x. Oh my gosh. Be careful, like always look when you type it in. It was putting that all in the denominator. So it should be 1/8 minus 12x, like that. All right, now we can look at these. They are clearly two, what are they doing down here? But we can see our two lines are clearly parallel. If we keep zooming out, they don't get any closer together. They never intersect. So these would have zero solutions. So that's just one way to verify that your answer is correct. I think it's worth doing, especially if you have time left. And it's just to be 100% confident in your answer. A lot of the systems answers, you'll know if you're right or wrong when you do it. Right? Like the only way that you won't get the answer is if you can't figure it out or if you're running out of time. But you can answer any systems and either plug in your answers and see if they work for both equations, right? If it's like x comma y, or you can graph it and see where they cross or see that they never cross, things like that. Now, I guess the one other way you could mess them up is even if you solve for the right ordered pair, always look for what are they asking for. Like in this case, they're asking for r. Sometimes they'll ask for there was one earlier, it was like what's 7x plus 8y or something like that. Maybe I reverse the coefficients there. But just always be careful, what are they looking for? Like for this problem, we're going to be doing what is the value of t, right? I haven't even read the problem yet, but I know that's what we're looking for. We have our equations, and let's see, is this one a little bit clearer where one starts and the other ends? Not really. I think it looks like the gap between the 2 and the t is bigger than the coefficient in any other variable, so I would assume that's where it ends, but still so annoying. We get 4x minus 6y equals 10y plus 2, and our second equation seems to be t times y equals 1/2 plus 2x. In the given system of equations, t is a constant. If the system has no solution, it's another no solution, it's another one that's going to be two parallel lines, two lines with the same slope and different y-intercepts, what is the value of t? So we're going to figure out what value of t will make this true, that they have two of the same slope, two different y-intercepts. You know what, for this one, even though it's set up the same exact way as the last one, and I think that went pretty smoothly, and I probably would do it the same way that I did the previous question, where you get them both into slope-intercept form, you can find the slope that way. I'm actually going to do it using standard form, just to show how to do that method. Now, if you do it the slope-intercept form way and you're getting confused, just go back to the previous video. I walked through all the steps, and then see if you can figure this one out yourself doing the slope-intercept form way. But I want to get it into ax plus by equals c form. For this first equation, we have 4x minus 6y equals 10y plus 2. Basically, the only problem is that this isn't a constant over here, and we don't have all of our y's on the left side. So I'm going to subtract 10y from both sides. That gives me that 4x minus 16y is equal to 2. Right? Because over here it cancels. Negative 6y minus 10y is negative 16y. All right, so this is in ax plus by equals c form. And now for the second equation, we have ty equals 1/2 plus 2x. So the problem here is that we have this 2x over here. So I'm going to subtract 2x from both sides, and that gives me... Now, when you subtract 2x from both sides, you might be inclined to write it as ty minus 2x. What I'll urge you is to make sure that you have your x term first. Or, what I'll really urge you is probably just do it the slope-intercept way, because you'll probably be less likely to make a mistake that way. But just in case you want to see how to do this, you could subtract 2x, but make sure that minus 2x is at the front, right? Because you have ax plus by, or just make sure that, again, that it's a parallel structure to the previous equation, so it's easier to compare them. So negative 2x plus ty is equal to 1/2, and then this positive 2x and negative 2x cancel out. All right, so now we've got this in standard form as well. It's ax plus by equals 1/2. But you can see our a value is different, right? Over here we have positive 4, over here we have negative 2. So it's hard to compare these, right? We want to find what t would have to be to make these equations so the left sides can be the same. But let's just make the a values the same, so then we don't have to worry about that. Think about what would you have to multiply negative 2 by to get positive 4? Well, negative times a negative would be positive, and 2 times 2 is 4. So I'm going to multiply every term on the left and the right side by negative 2. Negative 2 times negative 2 gives us positive 4x, plus negative 2 times t is negative 2t times y, and then negative 2 times 1/2, the 2 divided by 2 is 1, so this is just going to be negative 1. All right, so now we have 4x minus 2ty, so both of them are 4x minus something times y, equals, and they have two different c values, which is actually good, right? Because even if we can get the left side to be the same, if the right side is different, that indicates that then the c over a value, so the y-intercept, will be two different values. All right, so all we need to do now is make sure that the left sides are identical. If the left sides are identical of standard form, that tells you that they have the same slope. So for our b values to be the same, then the b value here, which is negative 16, has to be equal to the b value over here, which is negative 2t. This negative 16 equals negative 2t. We can get t alone by dividing both sides by negative 2. Negative divided by negative cancels. 16 over 2 is 8. So that means that t is equal to 8. And you can plug that in. 4x minus 2 times 8, y equals negative 1. That would give you 4x minus 16y equals negative 1. You can see that has the same left side of the equation for the standard form as the first equation, or once we simplified it. And they have two different c values, which indicates they will be zero solutions, no solutions, because they're parallel lines. Same slope, different y-intercept. Again, I'm going to show you could type this into Desmos, and it will verify it. I'm going to type first the first equation as it was written. So 4x minus 6y equals 10y plus 2. If Desmos can do that for you, then it's worth just typing it in as is, so you don't have to worry about, did I mess up any of the math going from this original equation to the one in standard form or in slope-intercept form, whatever. And then for the second equation, I'm just going to write it as is, except with my value of t, so with my value of 8 plugged in for the t. All right, so the second one would be 8y equals 1/2 plus 2x. And just to make sure that even if it worked for this final equation I had, maybe I messed up while I was moving that function around. So if I messed up the algebra. So we'll erase the previous functions, and it did erase some of that nonsense down here. Maybe if I refresh the page, it'll be better. Yeah, that looks better already. 4x minus 6y equals 10y plus 2. Right, so it's one equation. The other one should be a parallel line. So same slope, but different y-intercept, and they should never cross. So we had 8, or it was t times y. We're putting in 8 for t. So 8y equals 1/2 plus 2x. Oh, again, I did the same error I had last time, where once I started a fraction, I was typing everything in the denominator. So 1/2 plus 2x, right? That 2x should not be in the denominator. All right, so looking at it, we've got two lines. They are the same slope, different y-intercept. They're parallel. We can zoom way out. They are never going to cross. Okay, so right, if they were two different slopes, they would eventually be diverging, or they would converge and then they would diverge from there. But yeah, we got those two parallel lines, and that's what we were looking for, so we know that we got the answer correct. All right, this one's a word problem. It says, during a month, Morgan ran R miles at 5 miles per hour and biked B miles at 10 miles per hour. She ran and biked a total of 200 miles that month. 200 miles total in that month. And she biking, what was I doing in green? She biked for twice as many hours as she ran. What is the total number of miles that Morgan biked during the month? So this says, again, she She ran and biked, total of 200 miles that month. And we're trying to figure out what is the total number of miles that she biked. So just the biking. All right, well, we know R plus B, so the miles run plus the miles biked is equal to 200. So then we have times, she biked for twice as many hours as she ran. So to find the amount of time that you biked, we know the distance is equal to velocity times time, or rate times time. So in this case, our distance is either the b or the r, and that's equal to the speed. So either 5 miles per hour for running, or so we can write that as like the distance run is equal to 5 times the time. Let's say t r like that. I'm gonna do like that. For biking, b, the distance biking, is equal to 10, because it's 10 miles per hour is your velocity, times the time biking. So if we're comparing the time, she biked for twice as many hours as she ran. That means that the time is TB. So if we want to get TB alone, time biking, you divide both of these by 10, you get B over 10. So B over 10 is TB. And then to find TR would be equal to, you divide both sides by 5, we get R over 5. Okay, so divided by 5, like that. So we've got both of those things, and now I can write out this equation. She biked, so the amount, the time biking is equal to twice as many hours as the running, so 2 times TR, and substituting in this thing that uses the B and the R, you can say B over 10 is equal to 2 times R over 5. Okay, so that seems pretty good. And we're ultimately trying to solve for B, the miles biked. So what I'm going to do is substitute in R, right? Substitute in R in terms of B, so that I have an equation with only B's in it, and then that would make it easier to solve for B. So this is basically 2R over 5. 2 times R over 5, we just make that 2R over 5. Or you could say it's 2/5 times R. Right? Either of those will work. They're the same thing. But to get R alone, right, so you can do the substitution. We can multiply both of these by the reciprocal of this 2/5, so multiply by 5 over 2, both sides. And then we get 2 divided by 2 cancels, 5 divided by 5 cancels. So R is equal to, and then we would just do, right, divided by 5, this would be 2. So we get B over 4 is equal to R. And so B over 4 equals R. Now I can substitute in B over 4 to this other equation. So instead of R plus B, I'm going to write B over 4 plus B is equal to 200. And now I can just combine them. I'll just multiply this by 4 over 4. So we get 5/4 B is equal to 200. And then to get rid of that times 5/4, I'll multiply by the reciprocal of 5/4, which is 4/5. So multiply by 4/5 on both sides. This will cancel. We get B is equal to 200 divided by 5 is going to be 40. And then 40 times 4 is 160. So that means that Morgan biked 160 miles, which would mean that she ran 40. So R is going to be equal to 40. We don't need to know that, but that could help us check it. So if we know that R is 40, then that means that the time running is R divided by 5, so 8. So that means TR should be 8 hours. That makes sense. 8 hours times 5 miles per hour would be 40 miles. And then TB, you can find TB by plugging in our B value, 160, for that. So TB equals 160 over 10, which would be 16 hours. Okay, check that. 16 hours times 10 miles per hour would give you 160 miles. All right, so we got 16 hours biking, 8 hours running. Does that fit the criteria? I think they said it was twice as much. She biked for twice as many hours as she ran. Right, 16 is double 8, so that does check out. Okay, so this checks out. They do add up to 200, and the times, right, the biking time is double the running time. All right, so this one was interesting because a lot of times when you get problems that have to do with velocity, you're calculating for the velocity, and then you would use the velocity to figure out the distance, right? Velocity times time. This was interesting. They were solving for the distance. They gave us the velocity, and we didn't know the time, but we had to get the time in terms of the velocity, or time in terms of the distance. So this was a really neat problem. I liked this one a lot. A lot of these systems ones I feel like are really fun problems. I think a lot of my students would probably find them to be very tedious. They would be mad at me if I gave these to them in class. But these would be kind of fun, and just the more that you do these, the more comfortable you'll be with them. And I guess, again, should I show? I'm not going to show this time. If you wanted to put these in Decimus, once you get the equations, like the hard part of this is getting the equations. So r plus b equals 200. That equation is pretty simple. But getting, where's the other one? This equation, I guess, b over 4 equals r, starting from, I guess, like as long as you know to set up the time like this, and then what I guess you really only need is like the b over 10 is equal to 2 times r over 5. Right, like you can type that into Desmos, right? Type in this for one of your equations, type in this for your other equations, for your other equation, and then just solve for it. Make sure you keep track of which one is r, which one is b. Like it's going to graph it on an x-y axis, and you should be able to find 160 and 40 for your values of b and r. Just make sure you know which one's the b. That'd be the 160. In the system of equations below, well, this one's not below, it's to the side, but whatever. At least they're separated. We'll be happy about that. So the system of equations below, a and c are both constants. So they're both constants here. If the system of equations has an infinite number of solutions, so infinite number of solutions means that it's going to be the same line, right? So when you graph them, they're coincide, right? Every single point is the same. So every point on both of the lines is a solution. What is the value of a? So there's an infinite number of solutions, x, y. What is the value of a? So what value of a will make these the same line? It doesn't even ask about the c, but the c value also has to be a specific thing. But I guess we only have to worry about the a value, which is kind of nice here. Well, the two equations they gave us, we have them here. I'm going to rewrite them though. We have 1/2 x plus 1/3 y equals 1/6. And our other equation is a times x plus y, so it's like 1y, is equal to c. C is another constant. Anyway, we don't really have to worry about c for this one because they only asked us about the a. I mean, the c does have to be a specific thing, but right, they're just, I guess, saying you can leave it as c, right, and just assume that it is the right number. Now, we could get these in a slope-intercept form, and essentially all we have to worry about now is that the slopes are the same. Because slopes being the same could be parallel lines or the same line, but because they already told us there are infinite slopes and we're not worried about what the c is, then right, it's just a given that the y-intercepts are the same based on the context of this problem, but we need the slopes to be the same. The other thing we could do is what I did kind of on the previous one of these problems, so I think it was 2 questions ago, I just solved for it in standard form. And for standard form, 2 linear equations to be the same, and standard form, I mean, it's going to be annoying because we have an a and a c here, but usually you write it as ax plus by equals c, like that. For 2 lines to be the same, they need to have the left side be something that can be made the same. So you can make them the same a value, the same b value when it's in that format, when all the x's, all the y's are over there. And when those are the same, the c value would have to also be the same for it to be the same line, right? When the left side can be made the same, that indicates that the slopes are the same, because then your negative a over b is the same. For the right side to be the same, this constant over here to be the same, that indicates that the y-intercept will be the same, because c or b will ultimately give you that y-intercept. Okay, so what we want to do is start by getting this b term, right? This b term that doesn't have a constant there, right? They didn't give us a constant, to be equal to the b term of the first equation. So this one is 1/3 y. This is just 1y. So think, what do you have to multiply 1y by to get 1/3 y? You have to multiply it by 1/3, or you think of that as divide by 3. But you can't just multiply one term by 1/3. You have to multiply everything by 1/3. So this term, this term, this term. When I say everything, I mean every term. You don't multiply the a and the x. You just multiply the ax one time by 1/3. All right, so that gives us 1 over, well, I could say 1/3 ax, but I could write it also as a over 3 times x plus, this would be 1/3 y equals c over 3. So now you've got this, they're in the same form, and they have the same b value, right, the coefficient in front of the y. So now, again, if we want the entire left side of the standard form equation to be the same, that means that this 1/2, right, the a value, well, again, I'm going to be confusing here because I'm going to say a value We got a over here, 3 here. But this coefficient in front of the x for the first equation has to be equal to the coefficient in front of the x for the second equation, because it's already got the y the same. So a over 3 is equal to 1/2. And then to get a alone, we just multiply both sides by 3, which means a is equal to 3/2. So a is 3/2. If you plugged that in here, that would give you 1/2 x plus 1/3 y. And then they don't ask about the c, but basically, if you want these to be the same equation, right, so if you wanted to do this fully, 1/6, right, the c value here, or the constant value here over on the right side, has to be equal to the right side over here when you have the left side set up equally, right, like we do. So 1/6 would have to be equal to c over 3. And, again, to get the c alone, you just multiply both of these by 3, cancels here. And then 3 over 6 is the same as 1 over 2. So c would be equal to 1/2 to make this true. Again, don't worry about the c value. They didn't ask about the c. All they said is, what is the value of a? A has to be 3/2. Now, if this was a short answer question, you could also write that as 1.5. I would usually just leave it as a fraction, but it is a multiple choice, so 3/2. What you could do is plug in that 3/2, and even if you did it fully and you found that c was 1/2, that could help you. Right? Again, you don't need that for your answer. You just need this part. But you could plug it into this, right? So you could write like 3/2 x plus y equals 1/2, and see if it does plot the same line. Right? So we have 1/2 x plus 1/3 y equals 1/6. And then the other one should be ax plus y equals c, where a equals 3/2 and c equals 1/2. Okay. And even without finding the c, you could just see, are the lines parallel? Because that's the thing that we're finding. But I would, it doesn't take that long to add the c in as well. So I'm going to refresh the page, and then I'll write in, we had 1/2 x plus 1/3 y equals 1/6. That was the first given equation that had no constants in it. Okay, it looks like that. And now for our second equation, it was ax plus y equals c. I'm going to plug in my value of a that I found, which is 3/2. So 3/2 times x plus y, we could write 1y, but it was plus y, equals c. And my c value that I found was 1/2. And you can see it's right on top of the other line. Right? If we get rid of this one, the line is there. We add it back, it's on top. So these are the same line. That means every point on the line is a solution. So this has infinitely many solutions, which is exactly what they were looking for. And if you didn't even find the c value, just get rid of that. Oop. It should be, I guess you still have to type something in there. So even if you put like 0, you'll see they have the same slope. Right? And that's the thing that's controlled by that a value there. So right, that indicates, right, this would be 0 solutions, but that a value does give you the same slope, which is an important factor of having infinitely many solutions. You need the same slope and the same y-intercept. Again, 1/2 is how you get that. All right, so now I'm 100%. I was already very confident in the answer, but that's just another way you can check it really quickly, especially if you have some extra time left over. This one, this is not really one that would be, you could, I guess, guess and check using Desmos, but it's really not that tough to do. Just make sure that you're comfortable with recognizing if something's in standard form and you want to make a line that has the same slope or have maybe even a different slope or that has the same y-intercept or a different y-intercept, that you can do that by manipulating these coefficients in a way that is algebraically sound. All right, we have two equations. They space them well here. That's great. So we have y equals 4x plus 1 and 4y equals 15x minus 8. The solution to the given system of equations is x comma y. What is the value of x minus y? So I like to say, a lot of times when they ask for something that's not just x comma y, like in this case, they're asking for x minus y, that means that there might be a shortcut where you can solve for x minus y without figuring out what x is or y is independently. Now, it really does not take that much time to just solve for one of the variables, then use that to solve for the other one, then you get the ordered pair answer, and then you can plug them both into the equation and solve for it. Right? That would be fine. Now, if you're on the easy or medium section, it really probably does have a shortcut. Some of these do have a shortcut. Some of them, the shortcut doesn't save that much time, but whatever. But if we are looking at these, I'm not actually seeing a shortcut so much in this. So this one might have a shortcut, but I don't know. I'm not seeing it immediately. So what I'm going to do is just substitute. They already gave us y alone on this side. So I'm just going to plug in this value of y to the second equation. So instead of 4 times y, I'm going to do 4 times this equivalent value, 4x plus 1. And this is going to help me solve for x. I need to solve for x and y eventually, so it doesn't really matter which one I start with. But we get 4 times 4x plus, or 4 times the quantity 4x plus 1 equals, and then we have 15x minus 8. And now just make sure you distribute that 4. That's why I really specified the quantity that you put in parentheses. 4 times 4x is 16x. 4 times plus 1 is plus 4. That's equal to 15x minus 8. So now I'm going to subtract 15x from both sides. To get all my x's together, I'm going to subtract 4 from both sides to get the x's alone. So we get 15x minus 15x cancels, 4 minus 4 cancels. 16x minus 15x is 1x, so you can just write x. So x is equal to negative 8 minus 4 is negative 12. All right, so x is negative 12. And then if you want to find y, just plug it in. I'm going to use this first equation. So we get y is equal to 4 times x, so it's 4 times negative 12, the value of x we just solved, plus 1. 4 times negative 12 is going to give a negative 48. So negative 48 plus 1 equals y, which means that y is equal to, it's making it less negative, so it's going to be negative 47. So if our two answers are negative 12 and negative 47, we want to find x minus y. So be careful with that minus. So we do x, so negative 12 minus y, so minus negative 47, which is just plus 47. So negative 12 plus 47, it's going to, right, you have to add 12 to it to get to 0, and then you have an additional 35 that you can add to get up to positive 35. So 35 will be the answer there. For this one, if you use Desmos, you can find the ordered pair really quickly. I guess I'll check that to make sure that negative 12 and negative 47 is correct. Just make sure that, right, you set it up like this. So you do minus a negative is plus a positive. Right? Don't do negative 12 minus 47 because you're subtracting the negative, which means you're adding the multiplicative inverse of it. Okay. But I'll just show, and our equations are y equals 4x plus 1 and 4y equals 15x minus 8. I really think it's important that you know how to do substitution, that you know how to do elimination, and they do have some problems with the constants and stuff that we'll test that. So if you want to get a perfect score, you really have to know how to do substitution and elimination really confidently. But if you have a problem like this and you get Desmos, say you're really short on time, there's no shame in just plugging that right into Desmos to get x and y, and then just make sure again that you always read what do they want for the answer. Are they asking for x? Are they asking for y? Are they asking for an ordered pair? Or in this case, they want you to do something with the x and the y. Just make sure you do that correctly. So I'll open up Desmos now, and I'll move up here, plug in our equations. We have y equals 4x plus 1, and the other equation is 4y equals 15x minus 8. Right, so we have these two lines. I feel like they're parallel, but they're not, right? You can see they're getting further apart as you go up. They're getting closer together as you go down here. And I mean, that makes sense because that's where they cross. Negative 12, comma, negative 47. That's what we wanted. Right, from there, right, you could have just typed these in, found that point where they cross, and you may, you can also play around with your zoom settings here. So like, I don't know, say we want to make it, I guess, do we want to make it shorter or narrower here? Both pretty steep lines, so maybe we'll make it a little bit shorter. We can zoom in a little bit more on our answer. We said it's supposed to be negative 12, comma, negative 40 something, right? So we'd say, like this goes maybe from negative 50 to negative 35. And then for this one, let's go from negative 15 to negative 10. Right, so you can see right there. And they still seem really close together. But I guess they just have very similar slopes. So when you graph those, that's negative 12, comma, negative 47 for your point of intersection. And they were asking for x minus y. So you go x minus y would be negative 12 minus negative 47. And then maybe type that in your calculator. I know I did it by hand before, but just to feel 100% confident, negative 12 minus, parentheses, negative 47 gives you positive 35. Right? So it's the same thing we had before. This is just a way you could do it a little bit faster. You don't have to do elimination. You don't have to do substitution. And again, make sure that you know how to do those things before you take your test. But if you're really pressed for time, make sure that you use the tools that are available to you, and Desmos is one of those. All right, this is probably the last one I'm doing for now. It looks like I'm not even halfway through these, which is interesting. But we have a system. It's 7x minus 5y equals 4, and 4x minus 8y equals 9. If x comma y is the solution to the system of equations above, what is the value of 3x plus 3y? This is another one where if it was on the easy or the medium, I would look for a way to play around with this where you can go directly from combining them to getting this 3x plus 3y. There might be a way to do that, but I don't necessarily know that it's jumping off the page for me. Oh, actually, I'm looking at it. Okay. The reason that this is jumping out to me, these are 3x apart. These are 3y apart. So if we find the difference between them, which I think you have to subtract, I guess subtract the one I underlined in green. Subtract this from the top one. All right, so this one you could do the standard way. You could do either, you'd probably do elimination, or you could do substitution. You could do the graphical method. That's the fastest. Type it into Desmos, see where they cross, and then solve for that ordered pair, x comma y, which even if you do elimination, you would have to do then substitution to get the other variable, like the easier form of it, where you just plug in a value. And then once you have x and y, you'd have to remember, all right, what's the value of 3x plus 3y? You do have to plug in your x and your y to get that. But if we do it like this, so we get 7x minus 5y equals 4. And I always say I don't like to subtract. I like to multiply it by something. So let's multiply this 4x minus 8y equals 9 times negative 1. Right? So the whole left side and the whole right side by negative 1. That gives us negative 4x. Negative 1 times negative 8y is positive 8y equals, and 9 times negative 1 is negative 9. Right? We see I just manipulated that. You could also think of it as multiplying each term by negative 1. It's the same thing, multiplying the whole thing by negative 1. Is how I said it. So now if we combine these, 7x plus negative 4x, that would give you positive 3x, right? It's like 7 minus 4 is 3. Negative 5y plus 8y is going to be positive 3y. And then 4 minus 9, or 4 plus negative 9, will give you negative 5. And this is 3x plus 3y. So like I said, there's a way to manipulate it so you go straight to the answer. And a lot of times that will be the case. Now, if you can't see that immediately, don't spend 5 minutes trying to figure that out. I saw that pretty quickly. At first, I was about to give up on it. And then I was just like, oh my God, do I do elimination or multiplication? And then I saw, well, these are 3x apart, and these are 3y apart. So there's probably a way to do it. Because it's also just a weird thing to ask for, 3x plus 3y. If they had asked for x plus y, I might have given up. But anyway, negative 5 will be your answer right there. And if you don't see this, that's not the only way to do it. You could do it the standard way. But I just think that this is a nice little shortcut. Know that you should look for them. Don't spend, again, an inordinate amount of time trying to find that little shortcut. But if you do find it, it will save you some time for some of the other questions. All right, I will pick up from there the next time I'm here. Hopefully I'll look a little bit less tired. I think, I feel like I've been explaining these fine. Now, if I do break these up into separate videos, there's a possibility. I'll get the next part of these up soon. I'll make sure to put that in the video description. Go to the upcoming video. We'll have the rest of the hard systems questions so you can search them. I just noticed they're also, this set probably doesn't have the new systems questions they just added. I don't know how many they added. So that will be more things to add. So the next video will probably be longer. But anyway, you can see, all of these were substitution, elimination. You could use Desmos. Some of them were zero solution, infinite solution. Make sure that you're comfortable with standard form and slope-intercept form. I had to convert between the two different things. But I don't know, they weren't throwing anything too wacky in here. There were a lot of really interesting problems. I only had a few that I went over so far that were word problems. This was the only one where you had to choose the equation that fit for it. Maybe there's something else like that. But yeah, systems is one of my favorite topics to do in algebra. So hopefully if you feel the same way, you probably found a lot of these problems to be enjoyable. If you hate systems, then you probably found a lot of these to be really annoying. But hopefully that these descriptions were helpful. If you found any errors or anything, I'm a little bit tired right now, so make sure to comment those below so that people can see that and I can get the feedback. Maybe I can adjust it in the next part of this video. And if you found this helpful, if you liked this description and found these explanations to be a good combination of clear and concise and thorough, then make sure you like, make sure you subscribe. It will promote more videos like this in your feed, and it will just get it to more students who can then benefit from it. Hopefully, if you found this helpful. And besides that, best of luck with your preparation. I'll try to get the rest of these systems questions up soon, and then I have, I think, inequalities left for algebra, and I have all of the easy and medium ones for data analysis left to do, and a couple more easy medium for these. I think I have some questions I have to add in for some of the old ones because they just added a couple of questions for each set. So each set I'll have to do a couple. Maybe I'll just do like one video that's all of the hard algebra questions that were added since I last made those. And then I do still need to do all the ones that are in, I think it's called advanced math, which it's basically just like quadratics. I made a bunch of quadratics shorts. So if you're preparing and you're getting close to your test date and I still haven't made a lot of the quadratics videos, then hopefully those can be helpful, and hopefully there are other resources. I will try to get them soon, but just the quadratic sets are really long. Not that they necessarily take that long because you could get decimals and stuff, but like I think one of them, the hard section, has over 90 questions or something. So it's been very daunting to me because I like doing them in one big block. So I've been kind of pushing those off, doing the algebra ones, the data analysis first, where I think I can get them in a faster pace. But hopefully those will be up soon. And again, thank you for watching. Like and subscribe if you found this helpful. Comment with any questions. And best of luck with your exams and with your studying.